So one application is using SCR using rectifiers. So rectifier means you are going to convert an AC voltage into DC voltage. Okay, so SCRs are very much superior in performance than ordinary diode rectifiers. So rectifiers are usually made up of diodes, but if you want to have enhanced performance of these rectifiers, you will replace the diode by SCR. So some of the rectifier circuits have been explained. First one is a half wave rectifier. So half wave means you see the device will conduct only for positive half. Negative half it will not conduct. Sine wave, you know, it will have a full input, right? So you will be giving a perfect sine wave here. But the output of the circuit will have only positive half. Negative half will be zero because it is a half wave rectifier. So it will rectify only positive half of your sine wave. Negative half the conduction will not be there. And the diagram you see, you have a transformer, and secondary of transformer you connect to an SCR, and SCR is connected to a trigger circuit. And here you will have a load resistance RL to measure the output voltage. You have the load resistance RL to measure the output voltage. Vm is the peak value of your sine wave from the diagram. So during the negative half cycle, you see the SCR will not conduct because you know when the gate current is negative, the device is turned off, and you have a large reverse bias appearing across the device, so which will make the majority carriers to cross them. So in negative cycle, the current is going to be, the output is going to be zero. That's why you see the output is zero in negative circuit. Negative cycle, there is no conduction of SCR. In positive cycle, the AC voltage will be applying across the secondary. So you can see this positive voltage fully entering your SCR. It is available across the SCR. So SCR will conduct provided the gate current is made to flow. So depending on what is the input voltage, SCR will conduct. So SCR will not conduct immediately. It will conduct only after a particular voltage. So the greater the gate current, the lesser the supply voltage at which the SCR is triggered on. So the gate current is adjusted to a value such that SCR is turned on at a positive voltage V1. So you see here the SCR is not on immediately. SCR is turned on only at V1. So it will conduct only for this portion of your circuit. It will conduct only for this portion of your input waveform, sine waveform. The circuit is designed to ensure that SCR is turned on only at V1. So once your voltage reaches V1, SCR is turned on. Okay, SCR is turned on. Beyond this, SCR will be conducting till the applied voltage becomes zero. You know that once SCR is turned on, whatever input you give to the device, it is immaterial, and unless the input goes zero or negative, the SCR will be turned off. So SCR will be conducting until the voltage becomes zero. So the angle at which the SCR starts conducting is called as firing angle theta. Here you see in the diagram. So after this voltage V1, only SCR is conducting, right? So the angle corresponding to V1 is called as theta. So this theta is called as firing angle. So actually the conducting angle is 180 minus theta. Firing angle is the angle at which SCR starts conducting. The total conduction angle of SCR is given by this. The total sine wave is 360 degree. I am considering only one half. One half is 180. In 180, only conduction starts from theta. So remaining angle is going to be the conduction angle. So it is going to be 180 minus theta. So see here, therefore the conduction angle is 180 minus theta. Remember, firing angle and conduction angle are different. Firing angle is the angle at which SCR is turned on immediately. Conduction angle is the angle at which SCR conducts. Okay, so SCR will block not only the negative part of the applied voltage, but also will block the positive waveform up to a point SCR is triggered on. What they are saying is negative, you know, it is completely zero, and positive also, it will not respond immediately. It will respond only when it reaches the voltage V1. That V1 is going to be the break holding voltage. So minimum voltage it will reach, then only it starts conducting. So you should not blindly assume that SCR will conduct throughout the positive half cycle fully. No, SCR will conduct only when it reaches the minimum voltage V1, which is required for conduction. After reaching V1, you cannot stop the SCR from conducting. It will conduct as long as the voltage becomes zero or negative. That is what is given here. So don't think that SCR will block only the negative portion of the signal. No, it will block some portion of the positive waveform also up to a point where the SCR is triggered on. If the angle is theta, if the firing angle is 0, then there will be half wave rectification. So if you make this theta 0, then it will conduct for the positive half fully. So how you are going to fix theta will depend on what is your voltage V1. So the after theta only it starts conducting. Therefore, by proper adjustment, SCR may be made to conduct for the entire full positive half cycle or a part of positive half cycle, thereby controlling the power fed to the load. That is why silicon controlled rectifier can control at which point my device has to be on and which point my device has to be off. So by adjusting the circuit parameters, two things are possible. Either I can make the SCR conduct throughout the positive half cycle, or I can make the SCR conduct for a portion of the positive half cycle alone. Negative half cycle default SCR is going to be off. So how I am going to use the SCR to control the conduction in positive half cycle depends on the uh, what adjustment I am going to be giving to the gate current. So analysis, you can find the RMS value for a half wave rectifier. The average value of DC value is going to be Vm by 2 pi. The half wave rectifier, it is Vm by pi. For full wave rectifier, it is Vm by 2 pi. So you can find the RMS value. RMS Vrms equal to Vm by 2. The conduction angle is 0. The conduction angle is 0. Then the RMS value is Vm by 2, half of the peak value. And this is the DC value. Average value is Vm by pi when theta equal to 0, and it is Vm by 2 pi when theta equal to 90. So these are the two values for average. Average means the DC output, and RMS means since I am giving a sine wave, right? So it is going to be RMS output. And see here, I am going to take the limit from theta to pi because theta is the starting of conduction. I am not taking from 0 to pi. I am taking the I'm taking the limits from theta to pi. That is one thing you have to observe in the integral. And integration, I am not going to explain you. Integration is known to you. So I am using the basic formulas for integration. Okay. So any doubts in, we have seen SCR in detail, and we have seen the application of SCR as a half wave rectifier.